In previous lecture, I already discussed introduction to proof. There I discussed there are mainly two types of proof. One is direct proof, another is indirect proof. I already discussed direct proof with example. Let's discuss indirect proof. So first type of indirect proof is proof by contraposition. If we are not starting with premises and not ending with conclusion, then that is a indirect proof. If we are starting with premises and ending with the conclusion, then that is a direct proof. Like if P is true, then we are trying to prove that Q is true. Proof of contraposition is a type of indirect proof. I already discussed contrapositive. For implication P implies Q, its equivalence to its contrapositive, its negation Q implies negation P. Both truth value are same. So P implies Q is equivalent to negation Q implies negation P. Now in proof by contraposition, rather than assuming P true, we assume negation Q is true. Then by using axiom, rule of inference, different theorem, we'll try to prove that negation P is true. So this process is known as proof by contraposition. We assume negation Q is true and from that we try to prove negation P is true. Let's see one example. Example 3. Prove that if n is an integer and 3n plus 2 is odd, then n is odd. So if 3n plus is odd, this is our P, and then n is odd. It is our Q. So let me first try to prove P implies Q, means direct proof. So if 3n plus 2 is odd, then n is odd. So according to direct proof, let 3n plus 2 equals to odd means 2k plus 1. Here k is some integer. Now 3n plus 1, we just simplify it. So 3n plus 1 will be 2k. So how will prove that n is odd from this? There are no way. From 3n plus 1 equals to 2k, we cannot prove n is odd. Suppose you try to simplify it, 3n will be 2k minus 1. Then n will be 2k minus 1 divide 3. So is it odd? For odd, it should be in the 2k plus 1 format. It's not. So I stop here. Let's try to prove by the contraposition. Means negation Q is true. Negation Q is true means n is even. N is not odd. N is even. When n is even, we can write n equals to 2k. N equals to 2k means 3n plus 2. In place of n, we can replace 2k. So it will be 3 multiplied 2k plus 2. It will be 6k plus 2. And from 6k plus 2, we can take 2 common. After taking 2 common, it will be 3k plus 1. 2 multiplied by something, so it's also even. So this proof tells us that 3n plus 2 is even and therefore not odd. But this is a negation of the premises of the theorem. This is our premises and this is a negation of it. Here it's given that 3n plus 2 is odd. Premises is true, from that we are trying to prove conclusion is true. That's in direct proof. So in indirect proof, we consider negation of conclusion is true and from that we will derive negation of premises is true. So it's the negation of premises, that means n is not even, n is odd. So negation of conclusion is true. If 3n plus 2 is odd, then n is odd. So a proof by contraposition. If negation of Q is true, then negation of P is true. And finally, negation of P we found true, but P is true, that means Q is true. Next, vacuous and trivial proof. A conditional statement P implies Q is true when P is false. We already know truth table of implication. So P implies Q is false when P is true, Q is false, rest it is true. So when P value is false, whatever the Q value, whether true or false, P P implies Q is true. So that's all about vacuous proof. We try to prove that P is false. If P is false, then P implies Q is true. Next is trivial proof. In trivial proof, we try to prove that if Q is true, just check here. Here Q is true, here Q is true. In both cases, P implies Q is true. So if Q is true, then P implies Q must also be true. So a proof of P implies Q that uses the fact that Q is true called as trivial proof. So if P is false, then P implies Q is false, that is our vacuous proof. And if Q is true, then P implies Q is true, that is our trivial proof. Let's see one definition. Definition 2, it's about rational and irrational number. The real number R is rational if there exist integers P and Q with Q not equals to 0 such that R equals to P divide Q. A real number that is not rational is called as irrational. If you can write one number in P divide Q format, then that is rational. 1 by 2, that is rational. The number that is not rational is irrational. Next, proof by contradiction. Contradiction means always false. Tautology means always true. Suppose we want to prove that a statement P is true. So furthermore, suppose we can find a contradiction of Q such that negation of P implies Q is true. Negation of P implies Q is true and P is true. P true means negation of P will be false and Q value is false. So false implies false, it's true. So you can conclude that negation of P is false. Negation of P is false means P is true. This is proof by contradiction. So in proof by contradiction, negation of P implies Q is true, Q is false. When Q is false, negation of P cannot be true. If it will be true, then negation of P implies Q will be false. But it's given true. So that's why negation of P is false. Negation of P is false means P is true. So that is all about proof by contradiction. I just discussed basics of proof. For detail, refer the book. And with this, I am finishing introduction to proof. Also the chapter 1, that is mathematical logic. In chapter 1, I discussed propositional logic, propositional equivalence, predicate logic, that's about quantifier, then nested quantifier, rule of inference, and introduction to proof. If today's lecture is helpful for you, please like, share, and subscribe. Thank you.